Bismillah ar-Rahman ar-Rahim. We'll continue. This should be the last video for 2.3. I called miscellaneous questions, different questions there on there. Yeah, for example, this one. He actually will deal with it in section 2.4. Since sine is a continuous function, I can't take the limit inside. But what will happen? That will be sine limit x goes to 1, x secant square x minus tan square x minus 1. Since everything is okay with that x equal 1, so we can just substitute. So I have 1 times secant square 1 minus tan square 1 minus 1. What shall I do now? Yeah, you need to notice one thing. We have this formula. 1 plus tan square x equals secant square x. So you can think of this sine secant square 1 minus tan square 1 plus 1. Tan square 1 plus 1, this is for any x. That will be secant square 1. So this is secant square 1 minus secant square 1, which is always 0. So I have sine 0, which is 0. So the answer is 0. So just kind of calculation, but you need to be careful about the calculation. The same idea. Since sine inverse is continuous in its domain, actually we'll do this in 2.4 again. So I can take the limit inside. So that will be sine inverse. Limit theta goes to 0 of all of this. If you look at these ones, you think it's complicated. No, actually, when you substitute, there is nothing to worry about it. So that's sine inverse square root 2 plus cosine pi times 0, which is cosine 0, over e tan 0, which is 0, cosine 0. So that'll give me what? Sine inverse. Here I have cosine 0 is 1, so that's square root 3. E to the power tan 0 is 0, so it will be e to the power 0 plus 1. So it will be sine inverse e to the power 0 is 1, square root 3 over 2. When is that? Pi over 3. And that will be my answer. So it's kind of only calculation. The same thing, I can take the cosine inside, and this is continuous. So I can take it inside. So I have, no, I can take the limit inside, sorry. Since cosine is continuous, I can take the limit inside, like what we did before. So this is continuous, so I can take the limit inside. And the same thing there, this is what we did. So that will be cosine limit x goes 3 from left, pi over 2, greatest integer 2x plus 1. Now we need to be careful about doing this. Okay. 3 from left. So I'm thinking about x to be 2.99. Multiply by 2. That give you what? 5.98, something like this. Add 1. It will not reach 7. It will be 6.98. So what will be the greatest integer of this? That will be 6. So this function, this will be cosine. Now I can, this is pi over 2. Take it outside. The limit of this is 6. So it will be cosine of 3 pi, which is 2 pi plus pi. So it will be cosine of pi, which is minus 1. And that will be my answer. Okay. Now we'll talk about different type of questions, which is a little bit concept question. Is there a real number A such that this limit exists? He said this limit exists. What's the idea? If you look at the denominator, the limit of the denominator, limit x goes to minus 2 of the denominator, that will be what? Just substitute 4 minus 2 minus 2. The limit of the denominator is 0. Okay. Now, what will happen to the limit of the numerator of this one? Just to explain it, I said it's either non-zero or zero. There is no other possibility. Okay. Now, if you think about non-zero, this is impossible. Why this is impossible? Because if I have non-zero over zero, that is what? That's infinity category. And for sure, this limit would not exist. Either it go to infinity or minus infinity or does not exist. So this impossible. That the numerator is equal to the limit of the numerator is equal to zero. That means what? The limit of the numerator, that's the only possibility, should equal to zero. And just substitute to find A. What you will get, I'm taking limit x goes to minus 2, which is the same as this one. So I have 3 times 4, 12, minus 2a plus a plus 3 equals 0. So that means what? I have minus a, take it the other way. A equal 15. A equals 15. This is, we find the value of A. Now also you want me to find the limit. No problem. A. So I have everything. Limit x goes to minus 2, 3x squared plus 15x plus 15 plus 3 over x squared plus x minus. So I need to find this limit. Okay, so what is this? Yeah, this is 3x squared plus 15x plus 18. This is I can factor it. X plus 2 times x minus 1. Also the numerator, I can factor it. Actually, I can take 3 common factor. Let me save time. This is 5x plus 6. So that will be 3 x plus 2 x plus 3 over x plus 2 times x minus 1. This is cancelled. Substitute. You will get what? 3 times 1. I have minus 2 minus 1. That is minus 3. So the answer A is minus 1. So the limit will be minus 1. So we get the limit and we get A. The same idea. Now he put f of x. He told me this limit equals to 10. So it means this limit exists. Note, let me change to this color. Note, the limit of the denominator, easy to do, is 0. For sure, the limit of the numerator must be 0, as we said before. Now we need to find this limit, assuming it exists. So I have what? Limit x goes to 1. What is this? I can distribute the limit. Since I'm assuming no, the limit of f of x exists. Or you can do a trick, you add 8, subtract 8. You know, the same idea. That will be limit x goes to 1 f of x minus 8 equal to 0. So limit f of x goes to 1 will be equal to 8. All the exams. Now this is from all the exams, same idea. He said now this one exists. Actually, from the answers also, everything exists. The limit exists. No need to worry about. Note the limit of the new denominator equals 0. That means the limit of the numerator must be equal to 0. I don't care. This is 5 will not make an effect. Actually, just what I need the word exists. This limit, I mean, exists. Okay. So that means this is limit exists, this is limit exists, this is limit exists. I can distribute the limit. So limit x goes to 2. X, f of x, minus limit x goes to 2 of 6. This is will be 2. Limit x goes to 2 of f of x. Minus this should be equal to 0. Minus 6 equal to 0. That means this limit, which I'm looking for, will be 6 over 2, which is 3. Yeah. The same idea. Let me do it quickly. This limit of the denominator as x goes to c is 0. That means limit of the numerator. Yeah, maybe I need to do something here. Plus x minus 1. That limit should equal to 0. Okay. Now this limit exists. yeah, assume it exists. This is exist. This is exist. You can distribute the limit. I mean, from the answer, this limit exists. So this limit actually is the same as that limit. I will show you now. They are the same. X minus C plus C plus minus 1 equals 0. That implies limit x goes to C f of x minus C equal 1 minus C. What is my question? My question is the limit x goes to 0 for f of x, not this one. By the way, they are the same. How they are the same? If we do this trick. Let me deal with this. Limit is goes to C f of x minus C. Let t equal x minus C. See what will happen. That implies limit f of t. I took this t. Now, if x goes to C, x goes to C, I have C minus C. So t goes to what? To 0. So this one is similar to this one. So that means limit as this goes to 0 or t goes to 0, who cares? It will be 1 minus t. So that will be my answer. Okay. So it's the same idea, but with a shift, huh? Okay. Now we said this limit is equal to L. Find L. It means the limit exists. Yeah, by the way, this was term 212, okay? So I have the limit of the denominator. You want L, huh? You want the limit, huh? The denominator will be what? The 9 minus 3 minus 6, which is 0. Okay, that means the limit of the numerator should be equal to 0. I think we did something similar. So that implies 9 plus 3a plus a minus 13 equals 0. So I have 4a minus 4 equals 0. So very clear, a equal 1. Plug it. I need to find the limit now. So I have limit is goes to minus 3, x squared minus x plus 1 minus 13 over this. Yeah, what is the numerator? Actually, it's x squared minus x minus 12. I can't factor it. Let me do it here. That will be limit. X goes to minus 3. X, yeah, I need the minus 4 and plus 3. Okay, this one, I need plus 3 and minus 2. Yeah. So this is cancelled. Substitute. You get 7. You get minus 7. Huh? Minus 3 minus 4 minus 7 over minus 5. And that is 7 over 5, which is this one. And I'm almost the same, but he make it a little bit complicated. You need the square root. So when you do the limit, you need to do some rationalizing. Okay. First, he said this limit exists. So I need to find A or B. I need to find B in this case. So since the limit of the denominator equal to 0, as x goes to 0, I'm dealing with 0. So that means the limit of the numerator, look, the same idea. I'm just repeating myself. Huh? This should be equal to 0. That implies square root of 2, square root of b equal to 0. So very clear, b equal 2. We get b. Now we need to get a. So I need to find this limit. So limit x goes to 0. I plug the b. Square root of 2 minus square root of ax squared plus 2 over x squared. Okay, I know that this limit be equal to this value. Now I need this value. So I need to find this limit. Let me do it by the rationalizing. And the answer should be equal to 1 over square root of 2. 2 plus ax squared plus 2 over itself. So that will be limit is goes to 0. I have what in the numerator? 2 minus ax squared minus 2 over x squared square root of 2 This is cancelled. Also, x squared cancelled. So I'm getting what? Minus a over x goes to 0. I have square root of 2 plus square root of 2. So it will be 2 square root of 2. And now this limit equal 1 over square root of 2. So what will be? I have minus a square root of 2 is 2 square root of 2. So a will be minus 2. This is a. Square root of 2 cancel. This is b. So a plus b will be what? Minus 2 plus 2, which is 0. That will be my answer. Same idea. Okay. From here, I'm getting that since the limit in the numerator and the denominator equal to 0, for sure the limit in the denominator, in the numerator, should be equal to 0. Yeah, we did that before. So that means the limit of f of x as it goes to 1 equal to 4. Now what he wants this. This limit exists. This limit exists. So we just substitute. Have limit goes to 1. F of x over x plus 1. That will be 4. And this one will be 1 plus 1, 2. So the answer is 2. Same idea. He wants this limit, given this limit exists, or equal to 3. Limit x goes to 2 in the denominator equal to 0. So the limit of the numerator should equal to 0. So I can distribute the limit given that limit of g of x exists. So I have 10 plus 2 minus limit x goes to 2 of g of x, which I'm looking for, is equal to 0. So limit of g of x as this x goes to 2, that will be 12. Just this will take the other side and divide by minus 1. Okay. Okay, now we have more different questions. Yeah. Yeah, this is the one with the shift. Just you notice here I have f of x plus 3, and that I have x plus f of x. So I need to change this one to that one so I can use the relation. So I will let t equal x plus 3. So this limit, which is I'm looking for, will be limit x goes to 2. Yeah, x goes to 2 of x squared times limit x goes to 2 f of x plus 3. You can do the substitution for all, or can do it for this one, because this is the main change I need. Now this one I leave it as is, but this one I let t equal x plus 3. So what you will get? You will get limit f of t. Now if x goes to 2, then t goes to where? Goes to 5, because it will be 2 plus 3. What is this one? This one is this one, exactly, which I know is equal to 2. And this limit is 4 times 2, so the answer is 8. Yeah. This is a tricky one. Some of you will just distribute the limit, which is mathematically not correct, but it will give you the same answer. But the idea is, if we have a plus b and a minus b equal to a value, alpha, and this is beta, how to find ab in terms of alpha and beta? Yeah, the idea is comes from where? A plus b all square. That will be a square plus 2ab plus b square. A minus b all square. That will be a square minus 2ab plus b square. Now, if we subtract them from this, I'm getting a plus b square minus a minus b square equal what? This is cancelled. I have 4ab. Means ab will be 1 over 4 this quantity. Okay. Now, what the idea is, I don't know that the limit exists or not, so that I can distribute it. You can distribute it only if the limit exists. By the way, if you distribute it, you will get the same answer. Okay, so I can use this trick. This equal to this, I can get AB to get the solution. How is that? So what we have AB equal 1 over 4 A plus B square minus A minus B square. Okay. Now, the product, the limit of F plus G exists, and the limit of F plus G exists also, since it's the same, huh? So I can do now this limit exists, I can do the product of these two. So I can say the limit of x goes to 0 of the product of these two functions, of this function, they are the same. Square, that will be 4. And I can use the same trick for this one. This limit and its other ones, it will be the same. So I have f of x minus g of x squared, that will be 1. Okay. That means what? Since I have now let A f of x and let B g of x. So what will be the limit as this goes to 0? F of x times g of x. That will be 1 over 4 limit as this goes to 0 of the sum f of x plus g of x square minus limit of the difference. Okay, this limit exists. We agreed, and it's equal to 4. This limit exists, equal to 1. So what is my answer? 3 over 4. That will be the limit of the product. I don't know, yeah. The idea comes from here, from this relation. Okay. Yeah. Now this is true or false. If you have both infinity, it doesn't mean their difference is 0. This is wrong. If the limit of product exists, it doesn't mean that should agrees to f of 3, g of 3. Huh? It will be different. If none of them exist, the sum does not exist. No. When we did many problems like that. Yeah. If both limit does not exist, the sum may exist. Huh? We took many problems there. Huh? If the limit equal to 2 and limit g of x equal to 0, then what I have? 2 over 0 may exist? No. It either go to infinity or mass infinity. It will be infinity category. So this is also wrong. So all of these three wrong. The only one which is correct, if the limit of 1 exists, but the other one does not exist, then the limit of the sum does not exist. So exist plus does not exist means does not exist. But does not exist plus does not exist, no conclusion. We cannot conclude anything. Okay. I think this should be in 2.1 or 2.2. Yeah, this is the epsilon delta thing. Yeah, but the main thing is this one. If the limit exists, doesn't mean the value is the same, huh? And the same thing, if the value is equal to 0, doesn't mean the limit is correct. If the f is defined, doesn't mean the limit does not exist, huh? The limit is different than the value. This is the main point. This one, by the way, the precise definition, which is not with us. Okay, now we have just these two problems, which is, yeah, you need to be careful when you're dealing with them. Here, the problem is this, it's 1 over x. Actually, it's, yeah, if x goes to 0, yeah, what will happen to y equal 1 over x? This is the graph of 1 over x. Yeah, we should notice something. This is a curve, huh? We should notice something. The limit, as this goes to 0 from right, or 1 over x, from right, it goes to infinity. But from left, it goes to minus infinity, and that will make a change here. Okay. Why? Now, if I deal with e to the power x, let me just continue. E to the power x or e to the power 1 over x, let me say. I know the exponential function. Let me say e to the power u. The exponential function will be doing something like this. So if the argument goes to infinity, if u goes to infinity, y will goes to where? To infinity. If u goes to infinity, y goes to infinity. But if u goes to minus infinity, y will go to where? Minus infinity. Y will go to 0. Actually, we need 4.5 in that. Okay. So if I let x goes to 0 from right, then 1 over x goes to plus infinity, and the exponential of 1 over x, u is 1 over x. Huh? An exponential of 1 over x will go to what? To infinity. But if x goes to 0 from left, 1 over x goes to minus infinity. So e minus infinity will give me what? 0. Let me just rewrite it here. Limit x goes to 0 from right for e of 1 over x. Now let me do it in, let me rewrite it. X goes to 0 from right. 1 over x will go to plus infinity. So e of 1 over x goes to plus infinity. Plug it here. So we have what? Limit. Now if I'm doing from right, 1 plus x over 1 plus e to the power 1 over x. That will be what? 1 plus 0. 1 plus, this is goes to what? To infinity. 1 over infinity, that will be 0. Now, if it goes to 0 from left, 1 over x goes to minus infinity. So e is 1 over x goes to what? To 0. So the limit of this expression, which is we have here, 1 plus x over 1 plus e to the power 1 over x, will be what? Will be 1 plus 0 over 1. This goes to what? Goes to 0. And the answer is 1. From left is equal to 1, but from right is equal to 0. So it means this limit does not exist. Yeah. Let me finish this one. For n from left, n from right. I have this is n, but this is the greatest integer. I know that limit goes to n from left for the greatest integer of x. That will be what? N from left, less than n. So that will be n minus 1. But limit is goes to n from right, the greatest integer. N plus, it means I am more than n. So the answer is n. So what will be the limit? As this goes to n from left for f of x, which is the limit as goes to n from left for x minus greatest integer of x. This is just x, just a value. So this will be n, but this is give me n minus 1. So the answer is 1. Now what is the limit as goes to n from right of f of x? That will be limit as goes to n from right, x minus greatest integer of x. That will be n minus, what is this? N. We did it before. So the answer is 0.